In this lesson, I first want to start off by talking a little bit more about velocity, and then if we have time, I want to hop into something called acceleration. So basically, we know from the last tutorial that velocity equals distance over time. Now, the cool thing about this formula, and a lot of different formulas in physics, is this not only is the formula for velocity, but we can also use this formula to find the distance in time. So say we have a problem where we have the velocity and time, but we need to figure out the distance. When would this be? Well, say I dropped my sister off at the movie theater and I was a jerk and I didn't feel like picking her up, so she had to walk home. Now, it took her 3 hours to walk home. So we know that 3 hours would be the time it takes to walk home. So then we said, when she got home, hey, how fast were you going? And she said, well, I was walking at a rate of 4 miles per hour. Although she would probably say something like, shut up, don't talk to me, I'm gonna freaking cut your head off. But, she was nice and said, actually, I was walking at a rate of 4 miles per hour. So we know that 4 miles per hour is the velocity or speed. Well, now we want to calculate how far did she walk? Well, the first thing we need to do is we need to get distance on its own side of the equation. So how do we get distance alone? Well, we times this by t. So those cancel out and we end up with this. Distance equals velocity times time. So now let's go ahead and plug in what we have. Distance equals velocity, and I'm going to leave out miles per hour and hour. Velocity, or excuse me, yeah, a velocity of 4 and a time of 3. So now what happens when you take 4 miles per hour and times it by 3 hours? That must mean that you walked a distance of 12 miles, or she did. Sucks to be her. So that is basically how you calculate distance using this equation. Now, if you guys are wondering, what if I had the distance and velocity already, but I needed to figure out the formula for time? Well, time is equal to distance over velocity. So if you ever need to figure out time, then use this formula. So again, you can calculate the different variables of this formula by breaking it apart into different pieces. Pretty cool, huh? So now let me go ahead and talk to you guys about something else, and that is acceleration. Now, a lot of people get acceleration and velocity and speed mixed up in their head, but I'm going to try to give you guys a really easy example of how they're different. Say you were driving your car, and you put your car on cruise control at 45 miles per hour. Now, your car would be going a constant speed of 45 miles per hour and not be changing speeds. Therefore, since you aren't changing speeds, you are not accelerating. Acceleration is basically changing speeds. Okay, so when would you accelerate? Well, let's say you were at a red light and then that red light turned green. Well, you would then go from 0 to 30 miles per hour as you would accelerate. So therefore, since your speed would be changing, your car would be accelerating. Pretty interesting, huh? So let's go ahead and take a look at the formula for acceleration. Whenever we try to find out acceleration in physics, we use the small letter a. Now the formula is change in speed, and whenever we need to symbolize change in physics, we use a triangle. So change in speed, or change in velocity, same thing for now, even though they are different, over change in time. And I think I'm going to make my t's like this from now on. They're a little easier to see. So let's go ahead and take a look at that example. Let's say that we started out at 0 miles per hour. I say miles per hour, really weird. Miles per hour. Tongue twister, kind of. And we ended up going 30 miles per hour. And it took us, I don't know, 6 seconds. Give me a break, guys. I only got a cobalt and a neon. Embarrassing. So now let's go ahead and figure out this baby. So acceleration equals the change in velocity, which is 30 minus 0, over the change in time, which is 6 seconds. So now if we simplify this, that would be 30 over 6. And again, like I said, well, I might as well go ahead and throw these in. 30 miles per hour over 6 seconds. And we would end up with an acceleration of 5 miles per hour per second. So this right here is our final acceleration. And again, whenever we talk about acceleration, like I said in the last tutorial, just like velocity, we typically don't use miles, hours. We typically use meters and seconds. But for this example, this is how you would write it: 5 miles per hour per second. I know it's confusing at first, but well, that's just the way it is. So in other words, you start out at 0 miles per hour and your speed increases by 5 miles per hour every second. So that's why after 6 seconds, you're traveling at a speed of 30 miles per hour. So that's what acceleration means, and that's how you calculate average acceleration over 6 seconds. So anyways, that's all I have for you guys for this tutorial. Thank you guys for watching.